Next we go for the semiconductor RAM memory. In the semiconductor RAM memory, the basic internal organization of the memory chip, first we can explain it. There are memory cell can hold one bit of information at a time, where it can be accessed towards the array of logic, and one row can be act as your memory word length, where the memory word length is connected to the address by means of your status line or control signal lines. It can be perform the operation towards the data transfers. This is the internal organization of the memory, where it consists of 4-bit address decoder for an example. So it consists of a 15 word bit line, that is, sorry, 16 word bit line, where the memory cells can be treated as in terms of 3 to 4 memory cells, which can be controlled by the common parameter as a sense and read-write logic signal towards the data path outside D0 to D1 as a output. Next comes under the SRAMs. There are two types of cells. One is the SRAM cell and the DRAM cell. SRAM cell is nothing but static random access memory, which can perform the read-write operation in the basics of converting manner, where it cannot be erasable, whereas dynamic random access memory can be erasable. Here it consists of two transistors and two buffer logics as an inverter, which is connected to the board line. When the board line is connected to the ground, the transistor is in the off state, where the conventional output cannot be taken place at the initial state, whereas when the board line is one state, the transistor is on the state, and it can be bidirectional buffer logic, which can be used as an output towards the transistor series, where the static RAM is capable of retaining the state as long as the power is supplied. Access time of the static RAM is a range of nanoseconds, whereas its usually cost is high, whereas the dynamic RAM retains the state indefinitely, where the content can be refreshed at any time and the content may be rechanged towards the particular level. This is the basic structure of your dynamic RAM, which consists of one bit line and the burn word line. When both the signals are connected towards the transistor, the capacitor holds the data in a particular time period. There are two types of dynamic RAMs. One is the asynchronous dynamic RAM and synchronous dynamic RAM. In the asynchronous dynamic RAM, it consists of the separate row address lines and the column address line, which can be decoded towards the memory cells array as a logic, and it can be selected towards the control signals based upon the RAS and CAS. It can be coded as a latched output towards the output of the signal. For an example, 60 MB of DRAM can consist of 24 address line and 12-bit row address and 9-bit column address and 8-bit of data. One of the example is fast page mode. This is explained here based upon the group of selections of data which can be transferred as faster as random access, and it is also referred as a block transformation. It can be applied towards the selection of different bytes on the data lines. Next comes under the synchronous DRAM. In the synchronous DRAM, individual row address line can be decoded into a separate clock pulses, and it can be converted into separate clock signals. Based on the separate clock signals, it can be generated at the output of the DRAMs and the data transfer logic, which can be controlled by the read-write logic and CAS and RAS, which depends upon the dynamic random access memory, where the 21-bit address can be generated by means of the 32-bit address line, and also in the for a burst mode of operation, successive clock pulses can be used to generate the device in a particular specific operations. Here it affects the latency bandwidth of the DRAMs, where the latency is the time taken to transfer the data to a particular memory or from the memory, whereas the bandwidth is the number of bits transferred to a particular data streams. Static memory is nothing but your It consists of a logics of memory chips array in a particular PAL and PLD logics, which is incorporated with it 32-bit word length, and also it depends upon the basic bit size. It depends upon the chip size. So when the bit size is increased, the chip size is also get increases. And in dynamic RAM, it places a large memory cells, which affect the which also used in the occupying the memory space, occupy the space in the motherboard with a large amount of space, where the packages can be taken place in the memory chips by the small size of boards. The memory controller is recall of the dynamic memory chip, which is used to reduce the number of pins multiplexed using the two parts of addresses. One is the higher address mode and the other one is the lower address mode. The lower address mode is used to select the column line, whereas higher addressing mode is usually select the low address line by means of your array, and it also used to achieve the multiplexing the memory controller circuit inserted between the processor and memory. This is the basic structure shown for the memory controller. These are the basic semiconductor RAM memories and the types of memories.